Let's take a look at another application of linear systems in network flow. So we're to find the general flow pattern of this network that I've shown. And so in this network, really what we're looking at is each of the nodes, A, B, and C, and we're looking at the flow into those nodes and the flow out of those nodes. So we're going to work through this together, and then I'm going to run out of room, I think, on the actual row operations, but we'll do the best that we can. So for A, looking at the flow into A, I have x1, we can see by the little arrow here, and x3. So x1 plus x3 is flowing in, and the flowing out of A is 20. For B, the flow in looks like x2 and only x2. The flow out looks like both x3 and x4. And for C, I have a flow in of 80 right here, and a flow out of both x1 and x2. So far, so good. And then, of course, I'm going to look at the total, and the total is for the entire network. So flowing into the network is 80, and flowing out of the network is both 20 and x4. So what I have here is that x1 plus x3 equals 20, that x2 equals x3 plus x4, 80 equals x1 plus x2, and 80 equals x4 plus 20. What I want to do is write those in the correct format so that I have all of the variables, all of the x's on one side and the constants on the other. So this is going to turn into x1 plus x3 is equal to 20. This one is going to be x2 minus x3 minus x4 is equal to 0. This is going to be x1 plus x2 equals negative 80. And this is going to be x4 equals 60. So from here, I'm going to, I think I messed up on that 80. No, x1 plus x2 equals positive 80. Sorry about that. So now I have my system of equations. I can write it in the proper form, and I'm going to try to write this so that I can fit this all on one slide. Otherwise, it's going to get a little bit crazy trying to recopy things. So 0 or 1, 0, 1, 0, 20. Sorry if that's small. I'm trying to make sure I fit it all in. 0, 1, negative 1, negative 1, 0, 1, 1, 0, 0, 80, and 0, 0, 0, 1, 60. So that's where I stand right now, and just like always, I'm looking for pivots and I'm trying to, do the row operations. So I'm going to stick with this guy first for a pivot. And remember, once I have a pivot, then everything above or below that needs to be a 0. So this guy is going to remain the same. This guy's already a 0. Yay, less work for me. I'm just going to subtract the two rows to get that new row. So now I have 0, negative 1, 1, 0, negative 60. And this guy remains the same. So I just took row 1 minus row 3 to be my new row 3. Again, that guy is a pivot. Now I want this guy to be a pivot, so that means anything above or below that must be a 0. So that's what I'll do next. I'm going to turn this one into a 0, so this guy is going to stay the same. Sorry, I should stop saying this guy. Row 1 is going to remain the same, and row 2 is going to remain the same. And row 3, I'm just going to add rows 1 and row 2 together to give me 0, 0, 0, negative 1, negative 60, and row 4 will remain the same. From here, again, I've got a pivot here, I've got a pivot here, and it looks like no pivot here in 3, so now let's stick with a pivot in 4. So really I'm going to do 2 steps at 1 this time. I'm going to, for row 3, I'm going to multiply everything by negative 1. So again, nothing's changing here. in row 1. And in row 2, nothing's changing. Lost my place for a second. Row 3, I'm just going to take everything times -1. And row 4, I'm going to add rows 3 and 4 together to get 0, 0, 0, 0, 0. So obviously we can see that that x3 is a free variable. But now I have to continue because I need to, I have a pivot here. So I have a pivot here and all the zeros are good, and I have a pivot here and all the zeros are good. But obviously we have a problem right here at -1. So that's my next operation, is I need to essentially just add rows 2 and 3 together. And that's going to give me a final matrix of 1, 0, 1, 0, 20, 0, 1, -1, 0, 60, 0, 0, 0, 0, oh, just kidding, got a little 0 happy there, 160, and 0, 0, 0, 0, 0, and that's what we have. So what are we going to do from here? Essentially, I want the general flow pattern, which is the same as me saying what's the general solution. So the general solution is that x1 is equal to 20 minus x2, and that x2 is equal to 60 plus x3, and that x3 is free, and that x4 is equal to 60. So that answers the first part of this question. What's the general flow pattern of the network? That is the general flow pattern. Then it says, assuming all values are non-negative, what's the largest possible x3 value? So really the largest possible I did something wrong. I'm sorry. This is x3. 20 minus x3. That was important because obviously now the largest possible x3 value is 20, because 20 minus 20 would be 0, and anything greater than 20 would make x1 negative. So 20 is the greatest x3. And now that's answered both parts of our question. So again, notice I didn't write this as a parametric form, and that's okay. This is just the general solution, and then this is answering the second part of that question.